To Dan, Bruce, and everybody else who's involved, Tasha sitting back at the lead. It's a free event. The community has come together to put it together for you. I think that's absolutely brilliant. So, because I have imposter syndrome, I thought it would be a really good idea not to talk about web at all. We're going to take a break. I'm going to talk to you about MIDI, which is kind of interesting. My name is Ruth. You can find me on the internet as Rumira, so that's Twitter, GitHub, CodePen, all those kind of things. And the reason that I want to talk to you today about MIDI is to address a misconception. It's this misconception, right? Have that a bit louder, haven't we? This is a real website, by the way. Fantastic, right? CambrinsWorld.net. That's just a bunch of GeoCity stuff all sort of masked together. But the point there is that those sounds that you heard, this is not MIDI. That's a bit of a stretch. It's probably those sounds put together on a piece of software that was MIDI enabled, and the data is MIDI. But the sounds that you're hearing, that's digital audio. And when you say MIDI to somebody, they imagine that that's what MIDI is. And there's a reason for this, and it's a very, very good reason. I mean, MIDI itself stands for Musical Instrument Digital Interface. So people sort of get stuck on this musical instrument bit. And it's, it's about musical instruments, that's absolutely fine. But the really, really interesting bit, and the bit that I want to talk to you today about, is this digital interface bit. MIDI is essentially a data protocol. It sort of all came about because there was a rise of digital instruments in the 70s. They weren't the first digital instruments, but they got really, really popular. And so there was a sort of group of industry experts, musical instrument manufacturers, they kind of all got together and they started talking, and they were sort of saying, we've got all these really, really interesting things, but they can't talk to each other. Wouldn't it be really, really good if we had a specification for them to all talk to each other? So in 1983, they wrote one. And that was MIDI. And it came in sort of three parts. There's lots of different specifications today, and I'll take you through a few of them now. But the first specification was general MIDI. And there were three main parts to it. The first bit was general MIDI itself, which is the data protocol. So this is basically just how instruments, recording desks, everything would actually talk to each other. The second bit was a file format. It doesn't really exist as MIDI today. It sort of exists as parts of other file formats and sound formats. I'm not going to go into that today, it's outside the remit of the talk, but you can Google it if you want to. And the other part was this connector that you had to connect all these instruments together. This is a DIN connector. I'm sure that some of you have probably seen it. It's sort of been superseded by USB now, but it's a big, fat, round, sort of 5-pin connector. You needed an expensive sound card back in the day to sort of connect MIDI instruments to your computer. So it kind of made everything quite expensive, but it was part of the original spec, this connector. You can find out all about all this stuff on MIDI.org, by the way. I'm not going to go into every single thing in lots and lots of detail. It will make this talk very dry, but I will go into some of it. So general MIDI is part of the whole sort of core of it is messages. There's loads and loads of different messages. Again, I'm not going to go into them in lots of detail. I kind of did that before, and it makes this talk even dry. If you want me to talk about messages and the different types of messages you get in the specification, buy me a glass of wine and I will bore your socks off. There's two main types of channels and systems. Channels is, let's say you have a musical keyboard. These are the messages that when you press a key, data is sent. And it's all about what note you're playing, how hard you're pressing it, and everything like that. System messages is, this is a keyboard. When I'm pressing the notes and stuff, that's the information saying this is a keyboard. These are the settings that I have on this keyboard, so kind of system-wide messages. It's probably easiest for me to show this to you, right? Is everybody ready for this? This isn't, you know me, this wasn't going to be just a normal demonstration. You are going to need a device. I'm pretty sure you've either got your laptops out or you have your phone in your hands. You're going to need a modern browser. I'm sure everybody in this audience knows what a modern browser is. It's actually going to work. And the URL that you need is tiny.cc/webproc. And you should all, I'm going to have a little wall while you go there. You should hopefully be presented with a little keyboard of your own. If you're not, let me know. I'm guessing because Ben's shaking his hands, you've got one? You've got a keyboard? I've got loads in bar. only works in octavers. I didn't specify that. Okay, we might have something that looks a little bit like this. So if you press the keys on your keyboard, you should see some data, right? We've still got the URL on the screen, by the way, if we're still loading. How are we doing? Shout out if you're having one problem. Still loading? I will carry on. So I can demonstrate this to you. This is the sort of data that gets passed when you press keys, right? You should be able to see two bits of data. This is because you're pressing down and you're letting go. So there's a note on, there's a note on. I can step you through that. This is exactly what you'd see if you put your keyboard into your computer and you instigated the Web Midi API, right? So it's actually quite a simple API. All you do is request MIDI access on the navigator object, and then all I'm doing with this bit of code here is getting the data and just looping over the inputs and console logging them. There is a little bit that the Java class is doing, which is taking hex values, because you get hex with hardware, and then passing them into numbers for you, because that's much nicer as a developer. But that's basically all it is. Really, really simple, low-level API. What do those numbers mean? You've already seen we've got 3 values for the keyboard. We've got note on, which is the first value. So you press that down and get note on. 60, which is hex for C. So that's the note C. If anybody does any music stuff, you know the notes range from like A to G. So that's note C. And then 100, which is the last value, that's a velocity value. So the harder you press it, the higher that value is going to be. And it's the same for note off. You get very, very similar values. You just go 1, 2, 8 at the beginning because that's raising the note, right? And that's basically MIDI. That's it. And that's what we have on the web now. So we can go and get ourselves a MIDI instrument, and I'll take you through some MIDI instruments in a bit, and you can plug it in and you can get those values. And that's quite sort of powerful, really, if you think about it. That's nice data to play with. But what about sound? I already said that sound wasn't MIDI. And I did this talk at an evening event. I got to the slide where, what about sound? And someone shouted, yeah, what about sound? And I was like, did I not make myself clear about MIDI? Oh, never mind. It's alright. Web audio API. Right? Classic companion to Web Midi. So a lot of the demos that we see out there today use Web Midi and Web audio together to create the sound that you would do if you had a MIDI instrument. You get the data, you go, yeah, I've got these numbers, make these noises with these numbers. Or if you've got sort of more of a sort of slider or dial controller, you might want to alter that. Something else that we can do with the API. There are 4 sort of main ways to make sounds with the audio API. You can create an oscillator, which is just creating a waveform. You can grab it from the HTML elements, audio or video. You can stream it, which I've dubbed the Jake method of getting stuff, which is slightly different. It's a media stream sort of stuff, but it's still a stream. It's still the Bad method of getting or you can pass it into a buffer. So you can grab a file, you can pass that into a buffer, and then you can start and stop the buffer. A gotcha with that one, you have to create a buffer every single time you want to play the file. You kind of think by passing it into a buffer, it's kind of cached, and then you can start and stop it as many times as you want, but you can't. It gets me every time. You have to create the buffer every single time. Have we still got keyboards? Is that still a thing? Did anybody actually get one? Because we're going to need them again. So I wanted to illustrate the sound to you. So I'm guessing there's no one shouting out. We've still got keyboards. Thank you, Dan. Yeah, Dan's still got keyboards. Okay, that's cool. Thanks, great. So with any luck, we should be able to make sounds with your keyboards. Nope. Someone's making sounds. That's cool. So it's quite simple. All I've done is just grab some note files off the internet and then just attach those to the notes on the keyboard so that you can play them. I've got a better MIDI controller than you guys. Right? So this is my MIDI controller. I don't have it with me today. I can fit it in my suitcase, but it's really shiny, you'd think I'd be able to. So this is a controller, not an instrument, and I'll take you through the differences in a minute. And all I'm doing there is instigating the oscillator rather than grabbing a file, putting it into the buffer. And on the different pads, I'm getting different numbers so I can play different notes. So I'm going, now this is the number that I'm getting, play a different frequency of the oscillator. And then I've got some dials so I can add some distortion using some of the distortion notes that you get with the audio API. This is a really nice piece of very, very nice JavaScript. Wasn't written by me, but I'm using it. This is my friend Dave McIntosh. You can find it on CodePen. If you're interested in sort of plugging in a MIDI controller, if you've got one and sort of playing it, this does work with a lot of them, which is great. And it will just allow you, like I just plug mine straight in and it just allows me to play it, which is cool. Timing is really important in MIDI. There's a MIDI clock, and it's really important not just because you're playing music and everything's timed when you're playing music, but also with things like recording. I mean, you do a lot of sort of playing and pausing and rewinding music as well, so timing is really, really important. We don't have any timing with the Web Midi API. And the reason for that is, oh, I was supposed to illustrate that, sorry. If you had your keyboards, it doesn't matter. They were all supposed to ring at different times. But I'm guessing, are we still got keyboards? Oh, we're still got keyboards. There's some people nodding, that's cool. Okay, keyboards out, we'll see if this works. Right, okay. So you might have noticed there that everybody's phone is ringing at different times, right? So I just sent you some MIDI data to make your phone ring, because you don't just send it to me, I can send it to you, etc., just data, right? Now that's a problem with the web. We have this kind of latency thing. I'm sending messages, like we all struggled to even connect to me because we were waiting and we were buffering. This whole time things a bit of a nightmare. With MIDI, we can't really have that. It has to be really, really precise, especially when you're recording. Interestingly enough, I was pointed in the direction of this draft, which is sitting in W3C at the moment. It's the timing model object draft. You take nothing away from this talk today. If you're not interested in audio and video at all, go and read this draft. It's really, really interesting. And it's not just about MIDI. It's about a timing model which sits in your app. So it's to do with any kind of media, any kind of video, audio, animation, any of that stuff. Like the real-time stuff that we sort of do with WebSockets, I'm trying to do with you now. Like I could have, if we have this, which is a sort of object which you can instigate at the beginning of your app, and then you can time stuff sort of perfectly. I don't know how they're going to implement it, but it might work. I could probably got all your phones to ring at the same time, right? There's a couple of quotes to help you. Provide a unifying API for time operation and temporal control, and encapsulate complexity of distributed time synchronization. It's a really, really interesting draft, and I think you should go and read it. There's a machine control spec sitting in MIDI. So this is about recording, because instruments are taken into recording studios, and they are recorded. So MIDI sort of came out with a machine control spec to deal with the data for that. Funny enough, we have a very similar spec which has just come out in the W2C. We have a media recording API. Soledad's talking later, and I thought that she was talking about this because we just did a talk together a few weeks ago, and she did a really, really good demo of the media recorder API. But she's not actually talking about it, so I couldn't put no demos of this. But she has written a really, really good article about it, which you can find on the Mozilla hack site if you're interested. Basically, it takes any kind of stream and records it. So you can record what's going on your camera, your microphone, all that kind of stuff. And she does some really, really fun stuff with it, and sort of puts on canvas and puts filters on it and all the rest of it. But it's quite an interesting API, another one you should look at. Whew. Time out, a little bit of time out from MIDI. Specs. Specs, they're so exciting, right? I have a hangover, so I'm really enjoying all the specs. MIDI instruments, we're talking about them a lot, and there's a huge, huge range of MIDI-enabled things out there. But there is kind of differences between them. So here's a few, just to clarify what they are. We've already seen keyboards. Yeah, keyboards on your phone. You're probably all familiar with keyboards. You've probably all seen them. It's cheaper to make a keyboard that's MIDI enabled today than it is to not have it MIDI enabled. Because the little box that passes MIDI data is really, really cheap. They just stick them in keyboards. So that's what you're seeing in the top left there. The one in the middle on the top, that's a synthesizer. Now synthesizers are kind of beasts unto themselves. They're quite expensive because they have onboard audio. And they kind of create sounds, and you can put sounds on them, you can record sounds, and there's distortion, and they're kind of this weird instrument unto themselves, they really are. The one on the right, that's an electronic drum kit, which is MIDI enabled. So you can play the drums and make sounds, and it will pass MIDI data as well. The ones along the bottom, these are probably the most interesting to us as developers. You can see some people can't see that, sorry, I can't move it up for you. These are all controllers. So these don't have any onboard audio. These are pretty much just hardware, sort of buttons, dials, sliders, knobs, etc., right? The one on the left is probably most familiar to everybody. It's the Launchpad. It was one of the earliest ones. It's relatively affordable. It's about £70, I think, the original Launchpad. There is another one out now, which is a little bit more expensive. But it's basically just an array of buttons. And it works on USB, so you just plug it in, you press the buttons, and you get the data that I was talking about earlier. The one that I had earlier on the video, that's the Ake, they're even cheaper. Like this one's a NanoPad below it. Both of those are around £30. So you can just go and sort of pick one up, plug it in, and you've got buttons and dials to play with, which is great when it comes to sort of hardware enabling the browser. The one on the right is a personal one of my favourites because I have one. This is an Icon iDJ. And the idea behind this is you sort of pipe sounds to each side, sort of MP3s to each side, and mix them. But it's a really fun thing just to play with because, again, you just sort of plug it into your computer and you have access just to this data. You're just pressing buttons and sliding things, and you're just getting numbers. So that's a good idea of what the sort of hardware which we can have. And the whole point really behind it is it's affordable hardware. And we have so much hardware out there which we can use with JavaScript. I mean, there's things like Tessels, Esprinos, you can put Node on Raspberry Pi, but you've got this whole onboarding with it. And then if you want to actually use anything with buttons or dials, then soldering and it's time consuming. There's buttons, don't get me wrong, so if you just want to plug and go, you can go and pick up something for £30, and that's cool. It works in the browser. More specs. Does everybody need a drink already? Yeah, I think so. There's a show control spec. So what they found that when they released sort of hardware with MIDI, was everybody was using it on stage, because people were doing stage performances, and people started using it to do things like control lighting and control pyrotechnics. So they came out with a spec for show control. This has actually been sort of superseded really, because lighting now uses a DMX spec instead, and pyrotechnics, they have their own spec for sort of stuff. But that's fine because we have a visual control spec. This is actually my favourite MIDI spec because this is used in conjunction with sort of performances. And nowadays you don't really get sort of music performances that are just musical. There'll be like a visual performance as well, there'll be projections and all the rest of it. So this is to sort of talk about, or rather answer, and I will quote, MIDI visual control makes it possible to create visual effects that are synchronized with the musical performance. So I thought, let's do that. We still all got our keyboards, because I need your help with this one. If this one works, this is probably the one that's going to break the most. No? Okay, let's go here. So we all saw the Launchpad earlier. What I thought is we could crowdsource a very big Launchpad keyboard. So I'm kind of hoping that I can turn your keyboard into a Launchpad. Great, cool. So we've got some Launchpads, so that's great. So this is a different kind of MIDI control. It's not a keyboard anymore, we've got a Launchpad. The other thing that I was really interested in is this MIDI data, which if you look at it, when it comes to visual stuff, kind of looks like a colour. So that's like an RGB value or an HSL value. So I have kind of all allocated you a bit of MIDI data. You've all got different colours, basically. So when you're pressing your Launchpad, you should see that you're turning on and off different colours. Great, thank you, Dan's working, so that's enough for us. So this is all of you. Who you are, that's the game. You are your colour, right? So you're creating my visual performance, thank you very much. And then if I play some music, there's my mouse and go, then we can synchronise that in time, because obviously we've got an audio API, and we can analyse the audio. We can do some sort of crowdsourcing visual performance. Because it's the web, so we have to connect it to as well. People are actually trying to buy themselves, which is good. It's really good that you're doing it in time, so that's great. Thank you for letting me do that. So how did we do that? Well, we've already seen we've got Web Midi, so we're passing that MIDI data, we're sort of pressing the buttons. Web Audio, that was what I was using just to analyse the sound and just flash the different squares. There's also a Web Animation API, which is helping when we're talking about visual specifications, right? This is a really, really simple bit of code example for the web animation API. You just take the element, so you just take the Launchpad element and you .animate. If you use CSS animations, you'll notice that syntax is very, very similar. That's the same tech, basically. The thing about the web animation API is it does have a timing there as well, and animations are event-based. So although CSS animations and transitions and SVG animations are great in CSS, and they've been great fun to play with, this gives us a lot more power in JavaScript. And I think that's where it should really sit when you're talking about sort of time frames and sort of moving stuff and event-based things. It's really, really powerful. I'm kind of skipping over it, which is MIDI transport specifications. There are transport specifications. We've already seen the DIN connector. Today, everything's sort of USB. There is a USB web specification in draft, which I'm not really going to go into. It'll be really, really interesting to see how that sort of manifests with the MIDI API, because you kind of plug everything in via USB. So I'm kind of interested to see how those two are going to react. There is a Bluetooth Low Energy MIDI spec as well. So this is encoding and decoding MIDI data over Bluetooth. So they've started making Bluetooth-enabled MIDI instruments, right? So you don't have to plug them in at all. So they've come out with a spec to sort of answer that, and like, okay, we need Bluetooth to go, like MIDI to go over Bluetooth, better write a spec. That's going to be really, really interesting because we have a web Bluetooth API as well. I think this is probably going to be my next thing that I think of building. Get a Bluetooth-enabled MIDI device and see how the web Bluetooth API deals with it. It's under a flag in Chrome. It's kind of tricky. I would advise you, if you do want to play with web Bluetooth, buy yourself something with a new Bluetooth chip in. I've got some old BLE chips, and they're not great. I really struggle trying to get them to work. There's loads more developers .google.com site, and they go through all the different sort of protocols and all the things that you can pick up on. It's beyond the remit of this talk, I'm afraid. Possible uses for me. I mean, I talk about it a lot, it kind of just seems like a little bit of fun, right? People have been building stuff with it. This is MADEON's invention machine, built by We Make Awesome. I'm not allowed to swear and say. And this is a sort of a sequencer of sorts in a browser. And if you have a Launchpad and it will work with the Launchpad. If you don't, it still works. It's fine because you can software emulate this stuff. They've had 30,000 Launchpads plugged in. So this isn't something that just a few people have. People have actually got these and they're actually playing with them, which is great to hear. Navigating web pages is something that I was thinking about. I mean, we use the keyboard a lot. We have hardware to navigate web pages, and the keyboard's a great controller, but nobody's ever really questioned it. Nobody's ever gone, well, actually, the buttons are quite small. And if you struggle with small buttons, maybe something bigger, like the MIDI controllers I was showing earlier, the pads are bigger, and you've got sliders, which might be slightly easier to use. Could be a possibility. This is a really fun one. One of my friends, he does this. He hacks dinosaurs. On the Isle of Wight, there is a theme park called Black Gang Chin, and they do have these really, really big dinosaurs. And inside them, they've just got like metal skeletons, which you program with a Raspberry Pi, right? So you can move these dinosaurs. That you can program them. And we all know you can run loads on a Raspberry Pi. So basically, what he does is he hacks them. And he was talking about this at an event recently, and he was thinking of ways of making them more interactive. So things like putting a motion sensor on the T-Rex, and so when the little kids walk past, you can get them to glare them in the eye and sort of scare them. But there's also little dinosaurs, so you could grab a MIDI controller and get the kids, the little kids and the big kids, to move these little dinosaurs yourselves, just by sort of pressing buttons and stuff. Control your home. This is a desktop drum pad. So you're meant to sort of just plug it into your computer and have drum noises on it and play the sort of drums on your desk. But I kind of want to put one of these on my wall and sort of turn my lights on and off it. We all know all our homes are sort of connected these days, and so if you can program your lights and your heating and thermostats with JavaScript, then surely you can just stick one of these on your walls and, I don't know, disco light. You can get yourself a laptop, get yourself a MIDI controller, get yourself a little projector, write yourself a bit of software where you mix visuals and play music, and then put it all in like a handbag, which you actually strap to yourself as a Bachelorette tray, and go around the streets of your local city in the dark and project it onto pins, which is what I did before Christmas. That was kind of very cool. The kids, every single person that I was walking around with really, really enjoyed it. I wrote all about it on 24 Ways, by the way, if you want to if you want to find out about the software that I was writing. But it was all controlled by MIDI controllers. This was a talk about MIDI, and I hope that I've kind of given you something to think about, but it was also a talk about specification. I mean, the MIDI Association has been around now for 30 years, much like the W3C has been around for a long time, and they keep bringing out specs. They're talking about a polyphonic spec, which is about the new instruments they're creating, where you don't just press a button up and down, you actually can move your hands sort of around the keys and up and down, you can wiggle them, and they all produce sort of different sounds. It's really, really interesting in an industry when you get a group of people who are sort of clever and enthusiastic, and they give time, and they all talk about stuff, that they do keep bringing out modern specs. And that's kind of what we're still doing in the web, and I hope that it sort of carries on, because it means that an industry is long-lasting. And I said right at the beginning of the talk that there is a common misconception about MIDI. You talk to musicians, they all know about MIDI, they don't have any common misconceptions about it. You talk to web developers, they don't have any common misconceptions about how good the web is these days. Whereas if you talk to somebody else, they might think, oh, HTML is kind of a bit old, especially native developers. The MIDI world is in your web browser right now. JavaScript seems to be everywhere, right? Thank you very much for letting me talk.